So in this talk I want to explain why the classical labour theory of value is a special case of a more general theory, and in this general theory the well-known problems of the classical theory dissolve in a very natural and straightforward way. So the paper that accompanies this talk is in two parts. The first part examines multi-sector steady-state economies, and this is the simplest kind of model where the problems of the classical theory first arise. And the second part of the paper turns to nonlinear dynamics over multi-sector models. And there I present a minimal model of classical competition where market prices gravitate to natural prices. Now in this talk I want to examine the first part of the paper only. I want to present a simple but core argument, which is that classical labour values don't measure the total labour time to produce commodities. And this is a surprising result, which is why I think it's important to communicate, especially as it's the root cause of all the major problems of the classical theory. Okay, so let's begin with linear production theory and a steady-state multi-sector economy. So here we have three sectors of production which produce corn, sugar and iron. And we have a worker household sector which supplies labour to production. And the numbers here are the usual input-output coefficients. Now imagine we're looking down as if from on high and observing what's happening in this economy. Now although the economy is in a steady state equilibrium, there's a lot going on all the time. For example, there's a continual flow of goods to and from the sectors of production. Corn is produced and used by firms in the sugar sector to make sugar, and iron, in the form of agricultural tools, is used by the corn sector to make corn. And the level of the flows of goods between sectors depends on the technology and the activity levels in the economy. And nothing gets made without labour. So here I've drawn the supply of labour from worker households to the different sectors. And the actual level of supply, again, it depends on the direct labour coefficients and the scale of production. However, commodities get consumed too. So here I've added flow lines to represent the consumption of a real wage by workers. So for every hour of labour they supply, they consume definite proportions of corn and sugar. So at all times, commodities are both produced and consumed. And since this is a steady state, these flows are in equilibrium. So the net result is zero change in commodity stocks. But this is a money-based exchange economy. So therefore every commodity has a definite price. So we also observe, as we look down, flows of payments as commodities are bought and sold in the market. I've added flow lines to represent the payments between the sectors. And the payments flow in the opposite direction to the flow of goods. And the level of the money flows depends on the activity levels and the price structure. Also, workers get paid a wage rate and they spend that money to purchase their real wage. And again, since this is a steady state economy, these money exchanges balance. So the net result is zero change in money stocks. Now, in linear production theory, we express these steady-state flows in terms of linear algebra. So the quantity equation here is a material balance equation. Q is a vector of activity levels, A is a technology matrix, W is a real wage vector, and C is the consumption bundle consumed by capitalists, which for reasons that will become clear later I haven't yet drawn. And the price equation is a money balance equation, and it includes a flow of profit income to the capitalist owners of firms. And again, since this is a steady state, there are no arbitrage opportunities to reallocate capital to make greater profits. So a uniform profit rate prevails across all sectors of production. And that's what the pi represents in the price equation. And the quantity and price equation I've shown here are standard in simple linear production models. These are simultaneous equations that make no explicit reference to time. So the length of the production period is simply not specified. The important point is that within the production period, the flows of goods and payments happen simultaneously. Now, I want to ask a question. How much labour is supplied to produce each commodity type? For example, how much labour is supplied to produce 1 unit of corn? The answer is not simply the labour directly supplied to the corn sector, because to make corn you also need to make some iron inputs. So some of the workers in the iron sector are indirectly helping to make corn. So we need to measure the coexisting labour. That is the labour operating in parallel over many sectors of the economy that together contribute to making the corn. And to count this coexisting labour, we need to vertically integrate over this production graph. So let's start doing this. And I'm going to take this step by step in order to reveal the essential points. Imagine 1 unit of corn has been produced as output in the corn sector, and that's what the red dot represents. Now, making 1 unit of corn actually uses up some pre-existing corn, say in the form of seed corn. So I've drawn a red line to show the input corn needed to make a unit of output corn. We also need some iron to make the corn, so I've added another flow line to represent this input. And finally we need some labour. And this quantity of labour supplied is the first component of the coexisting labour that produces a unit of corn. But we can't stop here, because there's more labour yet to count. So far we've counted some direct labour, but we also need to count the labour that produced the iron and the corn inputs. So let's turn to that. And so here we begin the second iteration of vertical integration. The blue dots now represent the inputs that were used up in the previous iteration. We have a blue dot for the corn and a blue dot for the iron. And we have a blue dot that represents the labour supplied in the first iteration. The production of corn, represented as a blue dot in the corn sector, itself uses up some additional corn, iron and labour inputs. So I've drawn flow lines to represent these additional inputs. And in this second iteration, the inputs are getting smaller and smaller. We add the labour supplied to produce the corn to our running sum of the total coexisting labour. But we also have to replace the iron that was used up in the first iteration. So here I've drawn additional flow lines that represent the inputs used up to produce that iron. And we also have an additional supply of labour which helps produce the iron. And we add this labour to our running total. So each time we iterate, we add to our count of coexisting labour. And now we've got to an important stage. So far, in this second iteration, we've replaced the corn and we've replaced the iron used up in the previous iteration. But what about the blue dot in the labour sector? Do we replace this input too? I've drawn dashed flow lines to represent the real wage inputs to labour households. These commodities have to be produced and they require some coexisting labour to make them. So should we also vertically integrate over the real wage inputs too? And the answer is no, for a very simple reason. Remember, we're asking the following question. How much coexisting labour is supplied to produce 1 unit of corn? Or, put another way, how much labour is used up to produce corn? We therefore don't want to replace the labour inputs. We just want to count how many are used up. But for every other commodity, such as corn and iron, we do want to replace those inputs and ultimately reduce them to the labour supplied to produce them. And this means, in order to answer the question we're asking, we mustn't vertically integrate over the real wage. So we always ignore the real wage inputs in this graph. And we do this precisely because we want to measure the total labour used up to produce a unit of corn. So in this context, we treat labour differently. We treat labour inputs as a terminal point in the process of vertical integration. and I've represented this fact by drawing a black dot in the worker household sector. This is the point where all the paths in vertical integration eventually terminate. So we have no more work to do in iteration 2. But we're not finished. We now have to replace the commodities that we used up in iteration 2. So in iteration 3, we need to replace the corn and iron inputs that we used up in the second previous iteration, and I've shown these by green dots in the corn and iron sectors. And when we do this, we again add the labour supplied to our running total of coexisting labour. And we keep going, again and again, iterating backwards in the production graph until we get to labour inputs, which we add to our running total. And the input quantities keep getting smaller and smaller with every iteration until, in the infinite limit, the sum of coexisting labour converges to a definite and finite amount. And this final sum answers the original question. It measures all the coexisting labour supplied in parallel in different sectors of the economy that work together to produce a unit of corn. We can compactly express this operation in terms of linear algebra. And here the vector v represents the coexisting labour used up to produce each commodity type in the economy. So if there is n commodities, then that vector is of size n. And the iterative process as we trace input paths backwards is represented as an infinite sum with increasing powers of the technology matrix A. And the special status of labour as a terminus is represented by the multiplication of this infinite series by the direct labour coefficients L. If the technology matrix is productive, then the infinite sum converges. And we can represent the infinite sum in terms of a Leontief inverse. And this equivalent form in the second line represents a set of Sraffian vertically integrated subsystems. So the coexisting labour supplied to produce a commodity is identically the total labour supplied to the commodity's vertically integrated subsystem. The final equivalent form in the third line shows that coexisting labour is identically the sum of new labour added plus the labour embodied in means of production, which gets transferred to the output. And this is how Marx normally explained the meaning of classical labour values, although he also gave the coexisting labour interpretation as well. Now both interpretations are completely fine, and it's helpful to be able to swap between them. But the coexisting labour interpretation is superior because it emphasises that labour values measure the actual labour supplied to produce a commodity right now. So let's return to our original question. How much coexisting labour is supplied to produce a commodity? And the standard answer is classical labour values, as we've just seen. But is it the right answer? Did we really count all the coexisting labour supplied to produce a unit of corn? Actually, we didn't, and we missed some, as I'll now show. Let's go back to our steady state economy. I didn't really give you the full picture. This is a capitalist economy, where some households own the means of production, receive profit income, and spend that income on consumption goods. So let's add in a capitalist household sector. Worker households supply labour, which is why we draw output lines from workers to the different sectors of production. What do capitalist households supply to production? Well, in this model we exclude mixed households, and so capitalists can't supply labour. In reality, capitalists advance money capital to fund production. In return, they receive interest income on their loans. Also, capitalists own firms, so they are liable for both industrial profit and loss. And these are two different kinds of profit income, which in linear production models are often conflated or collapsed. For example, the price equation we're using has capitalists receiving a generic profit income proportional to the quantity of money capital tied up in production. So I've drawn dashed lines from capitalist households to sectors to represent the supply of money capital. But money capital is not an input in the usual sense, especially in the steady state. The dashed lines don't represent actual money transfers because in a steady state, the level of advanced money capital is constant and does not change. Loans neither increase or decrease. Instead, they are simply outstanding and capitalists receive interest on them. But there is, however, a reverse flow of interest income from each sector to capitalist households, and I've shown this with yellow flow lines. And capitalists receive this income because they fund production with their money capital. So, as production takes place, capitalists simultaneously extract profit income. And what do capitalists do with their profit? In a steady state, they don't invest to grow the economy. Instead, they spend their profits entirely on personal consumption. So I've drawn flow lines that show that, in this example, capitalist households consume both corn and sugar, in definite proportions, just like worker households. And now we have a complete picture of the steady state flows. Previously, we omitted capitalist households and their relationship to the production process, but this is very much part of the structure of a capitalist economy. So now I want to re-examine vertical integration given this additional structure. So as before, we ask the same question. How much coexisting labour is supplied to produce a unit of corn? So we place a red dot at the corn sector to represent that final output. As before, we use up some corn, iron and labour to produce a unit of corn. But now we see another input that previously we didn't consider. The production of corn must be funded, and the dashed line from capitalist households to the corn sector represents the money capital that funds the production of 1 unit of corn. And capitalists don't fund production for free, either in monetary or in real terms. Corn cannot be produced unless capitalists extract actual goods and services from the economy for their personal consumption. This consumption is part of the real cost of producing corn in the institutional circumstances of a capitalist economy. It's not a technical cost, but a social cost. So, during the production of corn, capitalists use up definite quantities of commodities, and these commodities require coexisting labour to produce them. And to count this labour, we need to vertically integrate through the capitalist household sector. This means that in the next iteration we must consider 3 rather than 2 indirect inputs, which I've shown with 3 blue dots. We need to replace the corn, we need to replace the iron used up in the first iteration, but we also need to reproduce the capitalist class at its given level of consumption. And here I've drawn the indirect inputs that replace the corn and iron used up in iteration 1. And here I've drawn the additional indirect inputs that represent the corn and sugar consumed by capitalists. So in iteration 3 we have, as before, some indirect corn and iron inputs to replace. But we also have to replace the additional corn and sugar consumed by capitalists. So I've drawn a new green dot in the corn sector and a new green dot in the sugar sector to represent these additional used up resources. And to simplify, I've combined the 2 quantities of corn that need to be replaced into a single big dot, and this just makes things easier to draw going forwards. So now we continue the process of vertical integration. Here I've drawn the additional inputs needed to replace the corn and iron used up in iteration 2. As before, we terminate at worker households and keep adding the supplied labour to our running total. But we also need to replace the sugar consumed by capitalists in iteration 2. So here I've added the additional inputs needed to replace that sugar. And the important thing to notice is that here, at iteration 3, we begin to completely diverge from how we previously vertically integrated. The input paths we trace backwards are now more complex, since we vertically integrate through capitalist households. And we're actually adding more labour now. We're adding the coexisting labour supplied to produce the corn and sugar consumed by capitalists in virtue of their funding of corn production. We missed this coexisting labour before, we didn't count it, but now we are. This labour isn't technically necessary to produce 1 unit of corn, but it is socially necessary in the institutional circumstances of a capitalist economy. So, as before, we repeatedly iterate backwards through this augmented production graph, adding all the coexisting labour along the way. At each step, the inputs, as before, get smaller and smaller, and the total coexisting labour converges to a finite value. And this final quantity also answers our original question. It measures all the coexisting labour supplied in parallel in different sectors of the economy that work together to produce a unit of corn. But the answer is different to classical labour values because it includes the labour supplied to reproduce the capitalist class. Once again, we can compactly express this quantity in terms of linear algebra. The vector underscore v represents the coexisting labour. As before, vertical integration is represented as an infinite series of matrix powers. But here, the matrix is the technology matrix augmented by a capitalist consumption matrix C. Each element of C is the quantity of commodity I consumed by capitalists per unit output of commodity J. The infinite sum converges if the augmented matrix is productive, and the Leontief inverse form in the second line represents a set of vertically integrated subsystems. These are Sraffian subsystems augmented by the production that replaces the commodities consumed by capitalists, and I call these the super integrated subsystems. The coexisting labour supplied to produce a commodity is simply the total labour directly supplied to the commodity's vertically super-integrated subsystem. The final equivalent form in the third line shows that this coexisting labour is identically the sum of new labour added plus the indirect labour that replaces means of production plus the super-indirect labour that replaces capitalist consumption goods. So I call these more general labour values the super-integrated labour values. So let's return to our question again. How much coexisting labour is supplied to produce a commodity? The standard answer, inherited from Ricardo and Marx, is classical labour values. But as we've seen, they don't count all the coexisting labour. They actually miss some labour supplied. Specifically, classical labour values fail to count the tributary labour supplied to capitalists, which is a real cost of production. So, if we want to know the total labour supplied to produce a commodity in the institutional conditions of a capitalist economy, then the answer is given by the super-integrated labour values. Classical labour values measure something else. They measure purely technical or natural real costs of production, independent of the institutional setup. And this is a surprising and important result. Contrary to conventional wisdom, classical labour values do not measure the labour supplied to produce commodities. Now, classical and super-integrated labour values measure different aspects of the same economy. They are therefore necessarily related. Classical labour values are independent of the price system and the distribution of income. Super-integrated labour values are also independent of the price system, but they depend on the distribution of real income. The total working day is the total labour supply during the production period, which is the dot product of the direct labour coefficients and activity levels, that is LQ. Now, it can be shown that the total working day equals the classical labour value of the net product. And what that means is that we can split the economy into Sraffian vertically integrated subsystems that together produce the net product and exhaust all the available labour. But we can now split the working day in another way. The total working day also equals the super integrated labour value of the real wage. So we can partition the economy into vertically super integrated subsystems that together produce the real wage and exhaust all the available labour. So we get a simple relationship between the labour directly supplied to sectors of production and the coexisting labour supplied to Sraffian and super integrated subsystems. All these expressions in the bottom line of the slide are alternative but complementary methods of partitioning the very same multi-sector economy. So now we can get to the punchline. Equilibrium prices measure the total money cost of commodities, but classical labour values, as we've seen, don't measure the total labour supplied to produce them. There's bound to be a mismatch if we compare total money costs with partial labour costs. And the conceptual error in the classical theory of value is to compare prices induced by the institutional structure of the economy with labour values induced by purely technical conditions of production. Apples are compared with oranges. And this conceptual error is the root cause of all the well-known problems of the classical labour theory of value. But if we measure coexisting labour properly and use super-integrated labour values, there isn't a mismatch. In the paper, I prove that the equilibrium prices of reproducible commodities are proportional to super-integrated labour values. In other words, the price of a commodity is the wage bill of the total coexisting labour supplied to produce it. So commodities that cost more labour time to produce sell at proportionally higher prices. And this theorem replicates the result established by Adam Smith for an early and root state of society, that labour embodied equals labour commanded. Now, the classical authors believe that natural prices diverge from labour values due to profits on stock, and this proposition has been universally accepted both by supporters and critics of the labour theory of value. But that proposition is false. The divergence arises only because classical labour values undercount the labour supplied to produce commodities in the institutional circumstances of a capitalist economy. Once we count correctly, we reveal the essential duality between money costs and real costs. So we get the essential elements of a more general labour theory of value. In this more general theory, we recognise multiple measures of labour value which answer different kinds of questions. For example, classical labour values are purely technical costs, independent of institutions. So if we want to investigate the technical productivity of labour over time, then these are the ones to use. In contrast, super-integrated labour values include social costs that depend on the institutional setup. So if we want to investigate the relationship between money prices and labour time, then these are the ones to use. We need both kinds of labour value, and in fact many others, to answer the full range of questions posed by a theory of economic value. So that's one of my core arguments. We need to generalize the classical theory to include multiple measures of labour value. And once we adopt this more general viewpoint, then all of the famous contradictions of the classical theory dissolve in a natural, straightforward, and illuminating way. So for those that are interested, you can see how all this works out in the references on this slide. Thank you for listening.